Hi everyone, I'm getting ready to start a new repair, and this is a Sega Gremlin Carnival power supply board. You take a look, it's on the bench right there. See that? This actually is from a customer that I repaired their Carnival board set. And he recapped, kind of rebuilt his power supply a little bit, and it's not working right. There's a note here. We can take a look at that and see exactly what this thing's doing. It is right here. Sega Gremlin power supply. Replaced arcade parts and repair cap kit. The big 9,000 microfarad caps. Okay, here's some caps here. Look new. Caps, okay. New caps, got it. Replaced tip 117. Replaced both tip 129s. No 5 volts. Negative 12 volts is negative 16 volts. When hooked up to the PCB, 12 volts goes down to nothing. Okay, so no 5 volts at all. 12 volts dies on load, and negative 12 is high. Okay, that's where we're starting. So we know we got new good caps. Didn't say anything about this being replaced. This could be open. So maybe there is 5 volts until there's a load on it. And I'd say probably the tip 129 or tip 29 or whatever might be the pre-driver for this guy. This has a tip 117. Is that a Darlington? Okay, it's got voltage regulators, obviously. It's got negative 12 regulator on here, I would say. What's this right here? That's 7905. Tip 29, tip 29, tip 117, tip 110, it looks like tip 110 maybe, I don't know, we'll have to figure it out. I don't see a negative 12 regulator on here, do you? This has one of those UA 723s. It has a voltage controller, so that could be bad. This is a op amp, 741 op amp. We got some diodes in here, and we got another chip over here. That's another 741 op amp. Okay, we have a big bridge right here, and it looks like that's the positive. That would be the negative. This is an AC input with the black wire. So there's only one AC input into this thing. We are only rectifying one part of the wave. And that's coming over to the positive cap and probably to that positive cap. Yeah, that's soldered right to the... this thing's weird. I'm going to have to get the schematic out. That's soldered right to the positive part of this cap. So I'm going to have to look at the schematic on this one. It looks weird. We are only rectifying one half of the bridge. We have the collector of the pass transistor right here. This is the collector to it. And the collector is tied to the center tap, maybe? So the collector is tied to ground. The collector is grounded. And this is the negative filter. Ground, positive. Okay, this is strange because we're not... Okay, that's AC. So AC is going to the negative... No, that's the negative DC, which is going to be... Okay, if we're not rectifying a full wave, then that's just going to be ground. I don't know. I don't know what's going on here. Yeah, this is going to have to definitely be a schematic look because that doesn't make sense. The negative part of this bridge is grounded. So how are we getting negative voltage? Oh, there's more lines coming off of that though. Yep, this is going to definitely, I'm going to have to look at the schematic, find out what's going on, kind of compare it to this, because this doesn't make much sense to me. So let's take a look at the schematic. Okay, after doing a little bit of looking, yeah, this thing is only rectifying the positive half of the wave for 5-volt circuit. The rest, the negative 5, the negative 12, and the positive 12 comes off of these 4 diodes right here. So that's a full wave rectification right there. Yeah. So power comes in right here on 1 and 3. That's the for the 110 to 120 volt tap right there and there. And this right here is your output voltages, which I have right here. I had to actually look on the PCB to find out what is what. So on the PCB, 7 is negative 12, which is 11. So 11 is negative 12, which 11 is right here. So it goes negative 12, positive 12, AC out to the PCB, that little 3-volt AC, and then you have ground, 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 negative 5, 5, 5, 5. So that's how that goes. So what I want to do is just put line in on this without a load and go through and check these voltages unloaded. Alright, I got my power cord out here that I kind of use for this kind of stuff, and it's got 1/4-inch tabs on it. And these tabs are 0.187, 0.188, the smaller size tab. So I'm not going to solder onto this. I want to get the proper tabs. So I'm going to go to the hardware store and buy some new crimp things and find a different cord because I don't want to take these off. I want to leave this the way it is. And I'll find another cord, crimp the 187s on it, and use it that way. Okay, so after doing some running, I went to a hardware store, I went to Home Depot, and could not find this 3/16 tab. I actually had to get these at the automotive store. So if you're looking for this size, it's 3/16 or 0.187. Quick disconnect. Yeah, you get them at the auto store. Home Depot did not have this size, so automotive store. And I've got some pieces of wire here I'm going to splice together for the cord and go with that. I didn't want to buy a new cord. Save some money and just use what I got. So, all right, let me put this cord together and then we'll be ready to fire this thing up. All right, I have my cord made. You can see right here the splice. It's nicely wrapped. And so you know, I do have my mains fused. I actually pulled the hot out of this strip and I have it fused. So if you are like doing this kind of work, you should have your mains fused. So it is. And we're ready to fire this thing up and see what we get. So I'm going to go ahead and put the camera on the tripod and we'll check it out. Okay. We'll go ahead and check her out. We'll go ahead and switch on. It is now on. We're on AC, and I'm going to just check the inline. And we have from the wall 124.4 volts in. Okay. Leave it on AC. Pin 3 should be 3 volts AC. That's pin 3. And there we do have our 3 volts AC. I'll switch to DC. Okay, we'll check 5 volts. And that should be 5 volts. And we have no volts. And then I believe it's -5, which we do have -5. This is -12 and +12. Okay, and that's our AC and then grounds. Okay, so the only thing that we're missing is +5. So, and yeah, after looking at the schematic, did I go over the schematic? Let's look at the schematic. I don't know if I went over the schematic with you all. Well, we can do that really quick. I got this turned off. I'm just safety. I'm going to unplug it. I don't want to shock myself. Get that out of the way. And I'm going to get this schematic down, lay it out, and we'll look at it. Okay, I have a rather large printed out schematic, bigger than I need. Here's the transformer, which is this guy. So you can see one side of the winding is ground. Remember that. The other side is going through and being rectified here and then set in ground for here. And then you have a 16.5 volt winding coming down and being full wave rectified by those 4 diodes. And then this before the rectification, you have your AC output here. That is your 3 volts AC. And your negative and positive 20 volts from this come down into all of this circuitry, which makes your negative and your positive 12. The 5 volt circuit's up here. And I don't know why they have a 3055 drawn as a Darlington. Because that is not a Darlington transistor. So I don't know why they draw that like that. Here's your 723, and The fact that we don't have any 5 volts, I'm suspecting that this guy's no good. Because we don't have 5 volts even without a load. So I'm kind of suspecting that this guy is dead. If we have, I'm going to check the voltage on these caps, and we should have about 10 volts right here on this cap, and about the same thing here on this cap, negative. So let's check those 2 voltages on these 2 caps, and if we have our right off the transformer rectified voltages on these caps, that would tell me that this guy's no good. Because this element right here is just passing, is a current amp. Yep, that is just a current amp. So it's passing the current through to the regulated 5 volts. So I want to check on these caps for that voltage. Okay. So let's switch on. Power supply is on. We're on direct current voltage, DC. Okay. This guy right here looks like our positive filter. So, and we have 13 volts right there. So that's good. And then on this one we should have a negative voltage, this cap. Yeah. Yeah, the negative is tied to the negative there. So one of these should read one of them should read a negative voltage. They both read a positive voltage. Yeah, and once again here, these 2 caps. Right here, I was probing my red probe here and the black one here, and you are getting, this is definitely a higher potential than this, so it'll read a positive voltage. Likewise, on the other cap, you have, this is basically ground, this side of this transformer, and then this side is the negatively rectified part of this wave. So this is a higher potential than this, so it'll also read positive. That just kind of threw me for a loop there for a second. I was expecting to see a negative, but it's not. If you look at the schematic, it makes sense. So that all checks out. Our voltage off of the transformer and onto these caps is fine. That just kind of tells me we have our 13, this thing is on. We have our 13 volts being rectified and showing up on both of these. So as long as, I mean, this thing, it's just kind of telling me this thing's no good. This 723. So I really want to replace that guy. And then these op amps, I can yank all 3 of these 741s and throw them in my tester to quickly just test those guys out. That's probably all that's wrong with this, would be my guess. So I will go ahead, let's take this board, remove the board, socket this thing, replace it, test these guys, and then see where we're at. Alright, doing a little inspecting on this guy. I trimmed these leads down. I'm going to clean that up really good and inspect it really good. We have some really bad solder joints here. That's the 5 volt. That's 5 volts right there. That's -5. So there's not a spot to do that on the top side of the board. Yeah, -5 is filtered right there. Then you got ground, ground, ground. And that is AC and +12 are looking shabby. So we got some resoldering to do on these connectors. Like I said, I'm going to remove these parts. And go from there. Kind of test. These transistors, I can just do a quick transistor test on this stuff. And verify that it's all good. Let me do all that, I'll be back. Okay, heating up the gun. I just went through, did quick transistor checks on these guys. This one looks like it might be open. And this one looks like it might have a short, but it might just be the circuit. Yeah, I'm just going to remove some solder from one of the legs and check it. But this one is reading as an open circuit, which it shouldn't do. So sometimes when you're checking transistors, it'll look like you have a short, but that could just be the circuit. But if you test one and it looks like it's open, you shouldn't get that. So I'm curious about this one right here. So I'm heating up the gun. We're going to do some removing parts and stuff and checking some stuff out. You know, that one that I was looking at, I was reading it as a NPN when it's actually a PNP transistor. I just can't hardly read it. But you can see this one looks fine. It's PNP. Yeah. PNP, not NPN. There. There. Okay. That looks fine. Now this one over here is a geez, I can't even hardly tell. That's also a PNP. And we can see that one. This is that, it looks, boy, that is absolutely short. No, it's, what am I doing? What's going on here? Yeah, that's the reading right there, which that could be absolutely fine. It just depends on the circuit. That's the other drop, but this one, base to collector, is that, and that could be fine. But I'll just desolder the collector lead and then test it. Okay, yeah, I just went ahead and removed that transistor, and you can see it tests fine. And base to collector is good. Emitter to collector is good. That's a 4403, 2N4403. I'm just going to replace it. But it's fine. So I'm going to go ahead and remove those chips and go from there. Okay, we have our old parts, which all of these 741s tested good, but they are rusty and crusty. Not looking the greatest. So we will replace them with some fresh new ones. This is a 3055 that did test good, but I'm thinking about upgrading and replacing that with a better transistor. The old, if we can find it, 3772. Yeah, I'm thinking about putting one of these in there. It's a much better transistor. I think I will do that for the long haul. I mean, just the beefiness. This one weighs way more. Dissipates more power, pushes more current. It's just a better transistor, so we're going to do that. We're going to replace that with a better one. So, new parts. Okay, now we have this board reconditioned. I got new op amps, 741s socketed, new LM723 socketed. I replaced that transistor. And there were so many bad solder joints on the back of this thing. From the diodes to just random, all of the headers had cracked. The input header had cracks on it. The output header had cracks on it. These were cracked. Just random stuff was cracked. The pots were cracked. One of the pots was cracked. So I went through and resoldered everything that needed it on here. And then I cleaned it up, of course, so it's nice and clean now. Somewhat. I'll just look at that really good, really close again one more time. But yeah. So we'll go ahead, I'll put this new transistor in it. I'll heat sink paste everything up really good. Insulate everything really good, and we'll come back. Okay, and we're put back together. Get that guy connected there. Plenty of heat paste, grease, heat sink grease. Okay. Yep. New parts, new amps, all resoldered good. So I'm going to go ahead, hook it up, and we'll fire it up and see if we have +5 over here. Okay, we're going to get this thing all set up. There's that. Zoom in a little bit. And let me plug in the power supply. Okay. And I will go ahead and switch it on. I am going into DC. Okay, it's on. And let's go to 5 volts. And we don't have 5 volts. We still don't have 5 volts. We have -5. We have our plus and minus. But we still don't have 5 volts. Alright, let's turn it off. I'm going to check this bridge rectifier, because that thing is the 5-volt circuit. It's setting the ground and the positive for that 5 volts. So I'm going to unhook everything from it. I'm just going to go ahead and unhook everything here. It is turned off. You know what, let me go ahead and do this and I'll be right back. I think I have figured out the problem. I got to looking up here at the schematic and looking at this pass transistor way up here. And I have my voltage on here on the collector. And I have my drop. If I measure from the base to the emitter, I can see my voltage drop by 0.7 volts. But on the emitter, the actual, okay, this is complicated a little bit to explain. I am measuring on the actual pin of the transistor. Bottom line, the socket for this is broke. And it's not getting through this transistor. So I will show you what I mean. Let me put the camera up on the tripod. I'll be right back. Okay. So I can measure, put the black lead on the base of that and the red lead over to the emitter. And I'm just getting on the emitter pin itself, not the actual part of the socket. And you can see there's your voltage drop for that transistor. That turns it on. But if I put my red lead on the actual pin of the socket, that's what I get. There is no volt. There's no connection. The emitter has that negative 13 volts from the base to the emitter pin. This is the actual pin right here. So the collector voltage is, there's no collector voltage. There's no voltage coming out of this at all. Yeah. Okay, so I'll see what I can do here. I might short something or solder that to that or something, I don't know. Okay, I have kind of very carefully got my tweezers shorting the emitter pin of the transistor to the actual connection on the socket. And it is connected now. I'm going to turn it on and see if I can measure 5 volts. And hope that this thing doesn't short. Okay, it is on, and of course I can't get to it. There's 5 volts. See it, 462? Okay, turn it off. I have to replace that TO3 socket, which I will do. I'm pretty sure I have one of those somewhere, so I'll dig one up and replace that. By the way, I did go ahead and unhook this guy right here and measured it all out in diode test, and it is fine. This bridge rectifier is absolutely fine. So the problem is just that right there, the emitter pin. This connection is broken. So I'll go ahead and replace that socket, and this thing will be good to go. And it'll be way better since I took this off, put new parts in it, kind of refreshed it a little bit, soldered all of those. I mean, this thing had a lot of bad broken solder joints on the back of it. And properly got that done to where it will cool properly. So yeah, very nice. And after removing this guy, you can see it's kind of blown out like that. Don't try, squeezing that back together and reusing it. This thing just needs to be replaced. So I'll go ahead, like I said, I'll find one of these and get it on there. All right, well, I found me a nice looking TO3 socket in the junk pile. Looks pretty good. So I'll strip all this stuff off of it and install it. Alright, I have replaced the socket. Now this one broke on me. So I had to pull another one off of a vector monitor down there. I pulled a socket off of that and soldered it in. And now if I take this lead and put it right here and then come over here and touch right here on the solder spot, not the pin itself, but the solder. Now there's continuity. So let's go ahead and plug this thing in and set our 5 volts. Okay, we are ready to go. So let's go ahead, turn it on. Okay, it is on. And we are reading 5 volts, 4.62. So, if I do, let's just put this like that, maybe. This like this, maybe. Maybe I'll get lucky. No. I don't know. Let's just do that and try to and no load. Let's go up to about right there. Let's go 525 without a load. Okay, and let's turn it off. And I want to put my 5 amp load across this thing, and I don't know if this thing is even capable of 5 amps. We're going to find out. I guess I should just leave this out, but I'll put the 5 amp load on it and we'll see if this thing can supply 5 amps. Okay, I have the 5 amp, the 1 ohm thing across this to pull 5 amps. And we're going to see what happens with our voltmeter. So pay attention to the voltmeter. And we'll switch this thing on and see if we get 5 volts. Alright, it is on, and no, we get 2 volts. This thing cannot supply 5 amps. Okay, so let's back it up. Let's make it about, I don't know, 3.5 amps. Alright, I had to remove, I removed half of this, so it's now 2 ohms. At 5 volts at 2 ohms is 2.5 amps. This is a 3 amp power supply. So right now it's sitting at 2.5 amps and it is at 5 volts. Right on the nose. So yeah, this is a 3 amp rated supply. At 5 volts, it just died. It just can't hold. It cannot do 5 amps. And that makes sense. That's kind of a little transformer. That's not a very big power transformer. It's only got the 1 pass element. It's a typical 3 amp supply. So yeah. But it's working good. 5 volts, right on the nose. I'm going to leave this thing running just like this for a while. Yeah. It's getting a little toasty. I might want to put that on something. I don't want to have that on here. So I'll go ahead and move this over to here or something like that. And just let this thing run for a while. But that is a power supply repair. Had a bad socket over here, a bunch of bad traces, bad solder joints. Redid the heat paste. I'm a little sloppy with it, but I believe in lots of heat paste. It's not expensive stuff. So paste it up. Reflowed everything. Replaced the amps and the regulator IC. All those parts were probably just fine, but whatever. I'm not worried about the negative rail being at negative, what was it, negative 15.5 volts. It's an unregulated supply, so that doesn't matter. You know, if you have positive 12, you have positive 13, you have negative 12 up to negative 15.5, it's not going to matter one bit. So, as long as you've got your regulated negative 5 and 5, which we do. Yeah, the negative 5 is right here. And our negative 12 is setting at negative 16 almost, which is fine because that, remember, that is an unregulated supply. And here's your 12. So yeah, it's good to go. 2.5 amps, 5 volts. Alright guys, I'm going to wrap this one up. Nice little power supply repair for you. A little refreshing. And it's going to do it. Thanks for watching, and we'll see you on the next one. Bye for now.